In this video, I'll be solving the third part of the first portion of UPSC Civil Services Mains 2018 Statistics Paper 1. So consider two independent and identically distributed uniform 0-1 random variables. So we need to derive the distribution of u, which is x by y, and we also have to find expectation of u. So here like x comma y are following uniform 0-1 and they are independent. So and like we need to find the distribution of u, which is x by y. So we can clearly see the joint PDF on this unit square. So fx comma y of xy. So that is 1 for 0 less than x less than 1 and 0 less than y less than 1. So we can use our transformation of random variables. So u is x by y and we can take v as y. So that implies x in terms of this u and v is uv, x is uv and y is nothing but v. So if I find the Jacobian here, so that's dou x by dou u, dou x by dou v and dou y by dou u and dou y by dou v. So that is nothing but, so differentiation of uv with respect to u, that's v, and differentiation of v with uv with respect to v will be u, and differentiation of v with respect to u is 0, and differentiation of v with respect to v is 1. So that's nothing but v. So the transformed joint density, so f u comma v of in terms of this u and v is f of x comma y of x comma y in terms of this u and v into v. That's nothing but f x comma y uv comma v into v. So and we know the joint density is joint PDF is nothing but 1 on this unit square, 0 less than x less than 1 and 0 less than y less than 1. So basically this is nothing but v. So now the region is 0 less than v is less than 1 and 0 less than uv is less than 1. Now 0 less than u is less than 1, this means this is 0 less than v is less than 1 by u. So that means like if we take the intersection of these two regions, so that is nothing but 0 less than v less than minimum of 1 comma 1 by u. So therefore like if we have to find the like the distribution of this u, so the density fu of u would be 0 to minimum of 1 comma u is so the joint PDF of f u comma v is v into dv, so that we'll get the marginal PDF of this u. So that is nothing but 1 by 2 into v square, sorry, like v square by 2 from 0 to minimum of 1 comma 1 by u. So that's nothing but half times minimum of 1 comma 1 by u whole square, and this u is greater than 0. So therefore like for 0 less than, u is less than or equal to 1, minimum of 1 comma 1 by u is 1. So that implies fu of u would just be 1 by 2, where 0 less than u is less than or equal to 1. But if u is greater than 1, then like minimum of 1 comma 1 by u would be 1 by u. So that implies the PDF would be 1 by 2 u square when u is greater than 1. And this is 0 for u is less than or equal to 0. So therefore, if we see the density fu of u, that's nothing but 0 when u is less than or equal to 0, u by 2 when 0 less than u less than or equal to 1, and 1 minus 1 by 2u when u is greater than 1. So expectation of u would just be integral 0 to 1 u into 1 by 2 du plus integral 1 to infinity u into 1 by 2 u square du, which is nothing but 1 by 2 into u square by 2 from 0 to 1 plus 1 by 2 u du, so that is 1 by 2 into ln u from 1 to infinity. So this part is just 1 by 4 plus ln u from 1 to infinity. So that means this is infinity. So expectation of u would be infinity, which means like it does not exist. So therefore this will be the distribution of u is equals to x by y, and expectation of u would be infinity, so that means it does not exist. So that's it for this video. We'll meet in the next video.